All right, so we're going to start out in chapter 1 by looking at solving equations. Okay, we're going to start out with some pretty straightforward type equations that only have one step, adding and subtracting, and then we'll get into one step, multiplying and dividing. So we pretty much solve equations all year. Pretty much everything that we do usually involves having to find the answer to an equation. Sometimes the equations are more complicated, sometimes they're simple. So if you think right now it's really simple, it does kind of build, all right, and especially next week, we'll get into some harder equations. Now, in order for you to have an equation, and I got to give you guys the guiding notes, what symbol does it have to have? Without this symbol, it's not an equation. Yep. So we can have some equations without parentheses. I don't think I have any examples.
Actually, you do. It's number 9.
These are all expressions because they don't have the thing that I'm looking for. But even though this has parentheses, that's not an equation. Yeah?
It's an equal sign.
Yeah, it has to have an equal sign. So what we focused on last night was simplifying expressions. Today we're going to solve equations. So the first thing I'm going to show you, you don't have to write down what I'm about to show you. You can just look at it. And then the next slide is the first thing to write down where it says to solve an equation. So this part, you can just watch this part. So one of the properties that we're going to use to solve equations today is called the addition property of equality. And you guys already used it in some problems from the warm-up. If you have something like this, the goal is to get the x by itself. What's preventing the x from being alone right now is a -3. How do you get rid of a -3? We call this the opposite operation. Yeah?
You plus it?
Yeah, you plus it on both sides. You add the same number to both sides. That's called the addition property of equality. And adding, as long as you add the same number to both sides, it will not mess up your problem. You'll have something equivalent, hopefully a little simpler than what you started with. So in this case, if you add the number 3 to both sides, and you could add 4 to both sides if you wanted, but that doesn't really help you. Adding 3 to both sides helps you because what's -3 plus 3? 0. Nothing.
Just cross it.
That disappears, and that's the goal when we're solving an equation, to get the variable by itself and get a number on the other side. So that's an example of adding the same number to both sides. Now there's another property we can use, and I think I'm going to talk about that one. Yeah, we'll talk about that one in a little bit. Okay. So what does it mean to solve an equation? Anyone have a thought on that? What do you think that means? To solve an equation. Yeah?
To find an answer.
Okay, yeah, to find an answer. And usually we're trying to get something by itself. What are we trying to get by itself?
The answer.
So yeah, the answer is going to be on one side.
X.
What's going to be on the other side?
You have to get X by itself.
It could be an X. A lot of times it will be an X. In general, what do you call that type of thing? The unknown, yeah, the variable. Yep. So when we're trying to solve an equation, we're trying to find the solution. And the way we do that is to get the variable alone. So you already have to solve an equation means to find the solution. If you have enough room, I know the next line is kind of close, but you could probably add that part in right there. When solving an equation, we want to get the variable alone on one side. Now the next thing that's on the board, I did this is you guys were giving the answers to some of the warm-up questions. Okay, I'm going to go back to the warm-up questions for a second because I remember one of the equations we solved had an R in it. Somebody gave me an answer, and I did something to see if it was right. So, which one was it? Oh, it might have been on the warm-up, not the homework. Yeah, right here. So this equation had an R, and I think at first somebody had said, oh, I think it's 10. And I said, okay, well, let's check it by plugging 10 in and see if 10 plus 19 gives us 39. And we saw that 10 plus 19 didn't give us 39. And then someone said, oh yeah, it's 20, it's not 10. So what we just did there, that's called checking your answer. Okay? You don't have to write that part down. But this is something we generally want to try to do, because if you check it and you see that it's wrong, you can fix it before I check it. Because it's always good if you figure it out before I do it. Okay? So what we'll do for some of these homework questions this week is we'll check our answer. We're not going to check necessarily every single problem you do all year, but I want to try a few of them just to make sure you know how to check your answer. All right. So a lot of people probably already know this from pre-algebra, so if you know it, you don't have to write it down. The next thing we're going to write down is the bullet that's on that page. But before I show you, can anyone remember how do you check your answer? Like if you had something like x plus 6 equals 10, and you thought the answer was 3, how would you check if 3 is the right answer to that problem? Yep.
You substitute 3 or whatever your answer is in for x.
Right. You substitute 3 in for x, and then after you substitute the 3 in, what would you do?
You would go about solving the equation and see if it comes out equal.
Right. That's the last part. You got to see, does it come out equal? Does what's on the left come out to what's on the right?
I was supposed to say that's wrong.
Yeah, that one doesn't work. So that means one of two things. You either made a mistake when you checked it, or the number that you plug in to check didn't work. So in this case, the correct answer is 4, not 3. So that's how you check it. You take your answer and you plug it back into the original problem. Again, there's not really a great spot to write that down, unless you want to put it at the top. You have a lot of room up there to put stuff. So if you want to write down how to check your answer, you can. If you already know how to do it, you don't have to. But checking your answer is really 2 steps. You plug the number back into the original equation. That's the first step. And then the second step is to see if you end up with something that's true. In this case, 9 equals 10. That's not true. That would mean your answer is wrong. Okay, so any question or anyone need to copy down how to check your solution? All right, so what we'll do now is we'll look at the first bullet point that's on your guided notes. So this is under the part that says chapter, that should actually say 1. Chapter 1, section 1, it's correct on your guided notes. Solving equations by adding and subtracting. So the first bullet, we have a blank line here on your guided notes. You want to put down, find the variable, which is the letter, on one side of the equal sign. So at this step, we're just trying to make sure we know what we're trying to solve for. So let's say this will be our example 1 that we do. find the variable on one side of the equal sign. Okay. What side of the equal sign is the variable on in example 1? Yeah.
The left.
Yep, it's on the left. And what is the variable that we're trying to find in example 1? What is it? Yeah, that's x. Yep. So we're trying to find out what the letter x is. And it's on the left-hand side. So in the problems that we do today, you're going to have a number that's on the same side of the equal sign as the variable. We got to put it on the other side. I'm just going to insert here, move number on same side of equal sign that's with the variable to the other side. So move the number that's on the same side of the equal sign with the variable to the other side. And in this case, to move this number to the other side, what math operation would you use to move -12 to the right side? Yeah, Marie?
You would plus 12.
You would plus 12. Does anybody remember what I called that? Like minus and plus. Those are called something operations. Like multiply and divide. They're begins with an O. Opposite, yeah. So when you move the number on the same side to the other side, you use the opposite operation. So for today, that means if you see a minus on this side, you're going to have to use a plus. If you see a plus, you're going to use a minus. Okay, so that's the second bullet point where you have 2 lines. I don't know if you need 2 lines, but you've got 2 lines to write it down. So these are the 2 operations that we're using today, either adding or subtracting. There won't be any multiplying, there won't be any dividing, there won't be any distributive property, there won't be any combining like terms. We're going to do all that. Not today. Yeah.
Is the next one just addition?
Addition and subtraction.
Okay.
Yep, it'll be both. So under the third bullet, you just have to write down add or subtract. And then the fourth bullet, that's the part where we check our answer, which means to plug it back in and then evaluate. And if you have the right answer, when you check it, you're going to end up with the same number on both sides of the equal sign. I think that's it. Okay, so what we'll do, I'm going to scroll back up because I want to do example 1, which that was up a little bit higher. And then we'll do example 1 together, and then maybe I'll let you guys try example 2. And maybe we'll do example 3 together, and I'll let you guys try example 4. Okay, so that'll be it, just these 5 examples for today. Okay, does everybody have the 4 bullets? Okay. So let me go back up to example 1. Example 1 on your guided notes, it's on the right-hand side. You've got a little bit of space to do it. So we already identified the variable. It's on the left. It's an x. And what's on the left side that we don't want with the x? Because remember, the goal is to get the x alone. So what's there that we don't want?
12. Well, -12.
A -12. We do not want that -12 there. So can someone remind me, how do we move negative 12 to the other side? And what operation did you just use? Addition. Yep. So what I like to see people do when they solve it, usually most people solve this kind of problem vertically. So then they just do plus 12, and then draw a line, and then we'll simplify what we have under that line. Carlos, when I do negative 12 plus 12, what is that going to give me?
Just X.
Yeah, just x and negative 12 plus 12 comes out to 0. So all you're left with is just x, because negative 12 plus 12 cancel out. And then that equals, and now we have to do the other side. Okay, the key with an equation is if you add something to one side, you have to make sure you add it to the other side. If you don't, then you get the wrong answer. So on the right side, we have 9 plus 12, and yep, that's going to give me positive 21. Okay, so that's what we think our answer is. How can we make sure that that answer is right? What's the word that we use for what we want to do now? Yep. Yep.
Substitute for x.
Right, we want to check our answer. So we're going to plug in the number that we got back in for x, and we're going to see if we end up with something that's true. True means we get the same number on both sides. So, Zach, what number am I going to plug back in for x?
Plugging back for X. What do you mean?
So we're going to check our answer. So
Okay.
what number are we checking to see if it's right?
21.
We're checking to see if 21 is right. Yep. So we're going to write 21 minus 12. And a lot of times what I do is this. I put a question mark above that equal sign because I don't know if it's right. I'm checking. So 21 minus 12 equals 9. All right? And now simplify what's on the left side. What does 21 minus 12 give me?
9.
Yeah, that does give me 9.
Oh, that's it.
I had 9 on the right. Is that a true statement?
Yes.
Yeah. So that means that the number 21 is correct. And we checked it, so we know it's correct. So when you have to check it, the directions will usually say solve and check. If you don't have to check it, then the direction would just say solve. So there should actually be a direction on that example 1. It should say solve up above it. But I didn't write that. So it kind of says it on your guided note, solve. So. All right, let's try example 2. So I'm going to give you guys a minute to try this one. And I want you to solve it, and then check and see if you got the right answer. Okay, so let's see if we can solve this one. Okay, we have 3 equals y minus 4. Okay, this time the variable is on the right-hand side. That doesn't change anything about how you do it. What's on the right side that we don't want with the y? Yep. Right, we don't want a negative 4. So we're going to use the opposite operation to get rid of a negative 4. What's the opposite operation of negative 4? Okay. Positive 4. So we're going to do a positive 4 on the right. And where else do we have to do it? Yep. We got to do it on the other side. You always have to do it on both sides. And now on the left, 3 plus 4. Marie, what's that going to give me?
7.
7. Perfect. Equals. And now let's simplify negative 4 plus 4.
Well, it would just be 5.
Yep, it would just be y, because negative 4 plus 4, what happens?
It makes it 0.
Yep, that's 0, so that's gone. And it's perfectly fine to write your answer with the variable on the right. If you want to put y equals 7, if you like writing it this way, that's the same thing. You can write your answer either way. Most likely as on Edge Elastic, it'll already be a box for you, so you're just gonna have to fill in the box. Yeah.
So for y, I got 1. The thing is, I realized no, it's not 1. And so
Yeah.
yeah, I had 1.
Yeah. So I think you might have like if this number was a -3 on this side, then when you add 4 to both sides, you would get 1. So you had solved it if the problem was like this, but we didn't have that.
What tricked me was the negative. Was the negative sign.
What's that?
What tricked me was the negative sign.
Oh, the negative sign. Yeah. Okay. All right. So we solved it. Now, off to the side. Let's check it. So Madeline, to check it, what do I need to do?
Put 7 and 4y.
Yeah, take the 7, plug it back in for y, and we're going to see if we get a true statement. So we have 3 equals, and then fill in 7 for y. Okay, and again, I'll put a question mark there because we don't know if it's equal. That's what we're trying to figure out. Simplify the right side. Evelyn, what's 7 minus 4? 3. So I get 3 on this side. I get 3 on that side. Is that a true statement? Yeah. 3 equals 3. If you get like 3 equals 2, then something's wrong. But that is correct. Good. Any question on that? All right, that was example 2. I think we have one more before we do the subtraction. So let me, you know what, you guys can, since it's the same one, I'll let you guys try that one. So it's 12 equals x minus 5. Okay, when you get that one, just let me know, and we'll come take a look. So no, there's no times here. So what's with the x that you don't want? Yeah, that you want to get rid of. What do you want? So that's okay. So we're trying to get the x by itself. So what is on the same side of the x that we don't want to have there? What's with the 5? The negative. So we have a negative 5. How would you get rid of what's the opposite of a negative 5? So you've got to do the plus 5 on both sides. Let's see. So like that, yeah, looks good. Yep. That and that looks good. Welcome. So you get that and then that looks good. Okay, so you get that and then there's so that's your answer. Where's your this is your check right here? Okay. Yep. Yeah, that looks good. Okay. You already did that. Okay. That looks good. Excellent check here. Yes, good. So to check it, you're going to take the number that you got, and you're going to fill it, you're going to write this. 12 equals, you're going to put whatever number you got right there, and then you're going to simplify it. So you just fill in whatever you got inside that box. Okay, so most people, if you had any trouble as I walked around, I asked you what's on the same side as the x that you don't want there. So what are we trying to get rid of? We're trying to get rid of this negative 5. And what do we do to get rid of a negative 5? We add 5. So far it's been adding for every problem. We are going to do the next operation in example 4. Okay, so negative 5 plus 5 cancels out. And how about Evelyn? 12 plus 5 is going to give me 17. So we get 17 equals x. And now the check, I already have it set up. Take the original problem and just fill that number in for x. So we got 17. And if we simplify it, what is 17 minus 5? Yeah. 12. So you get 12 equals 12. Perfect. Okay. Any questions on that? All right. So up until now, everything we've had to do is adding a number to both sides. So if I had something like this, let's say x plus 5 equals 12. Would adding a number to both sides, a positive, would adding a positive number to both sides solve that problem? No. Adding a positive number to both sides would just make the number on both sides even bigger. We're not trying to make the 5 bigger, we're trying to get rid of it. So what operation would we have to use this time to get rid of a positive 5?
Subtraction.
Yeah, we'd have to use subtraction. So the next thing I just want you guys to look at, you don't have to write this down. It's going to be subtracting from both sides. And that's called the subtraction property of equality. So just like we had the addition property, we have the subtraction property. The key for the subtraction property is you have to subtract the same number, and you have to do it on both sides. As long as you subtract the same number from both sides, you'll get something that's equivalent to what you started with, which means it's okay to do it. If you ever do something and it's not equivalent to what you started with, then you've now messed up your problem. We don't want to do that. Okay, so the two big ideas for today, you're allowed to add the same number to both sides of an equation, and you are allowed to subtract the same number from both sides of an equation. Any number you want. Any number. When we get to multiplying and dividing, we already know from yesterday there is a certain number you're not allowed to divide both sides by. Does anybody remember what number we're not allowed to divide by?
0.
0. So when we talk about multiplying and dividing, we'll say something like you can divide both sides by any number you want except the number 0. For this, though, there's no except the number. You can do any number you want. All right, so I don't usually let people try every problem on their own, but I think most people are doing pretty good with these. So I'm going to let you guys try this one on your own too. We'll walk around and check in. When you think you get the answer, just let one of us know. I want you to solve it and then check. So in this one we have x plus 6 equals 10. Okay. What number is with the x that we don't want that number there? Yep, go ahead. Yeah, we want the 6 to be gone. Okay. What kind of 6 is it right now? Is it a positive or negative? Yep.
Positive, so you have to subtract.
Yep, it's a positive 6. So we are going to subtract 6 from both sides. And when I do that, How about Lily? What's positive 6 minus 6?
0.
0. This is gone. So what am I left with on the left side now? Yeah.
Well, 6. And the answer will be 4.
So yep. So we get 10 minus 6 is 4 on the right, and then on the left we have
0. X.
x. Yep. So that's what we're left with. X equals 4. Okay, so we solved it. But what else do they want us to do? Yep.
Check it.
Check it. So we're going to check it. Take this one, fill it back in. So we have 4 plus 6. And the question is, does that equal 10? So if we plug it back in, Madeline, what do you think? Does 4 plus 6 give me 10? Yep. So I get 10 equals 10. And we are good. So that one checks. Okay. Any question on example 4? All right. Let's take a look. I think that's... Yep, the word problem. Okay, so just a reminder, again, you don't have to write this part down, but just so we remember what different symbols mean in math. If we have 4 more than a number, and let's say the number was n for number. Can somebody tell me, how would you write down 4 more than the number n? Yeah?
Like 4 times n? Or like 4 plus n?
Which one do you think it is? 4 times n or 4 plus n?
Probably plus.
Yeah, it's going to be plus. So I think that's what I put here. Maybe. There it is. Okay, so 4 more than a number. Another word you could see is increased. So if I said like a number was increased by 5, or you increased your test score by 5 points, that's a plus 5. How about this one? And this one we're going to be a little careful. 16 less than a number. And if you get confused, think of like 16, or think of, yeah, you can think of like 16 less than 20. Think about how you would figure that out. 16 less than the number 20. Yeah?
N minus 16.
Yeah. You have to be careful with the order. This one comes first. That one comes second. So this comes first, n. And then the minus 16 comes second. And subtraction can be a little tricky. That's why I try to think of it in terms of numbers first. Then I think of it in terms of the letter and go from there. Right, so any question on that? Because we're going to see these phrases, or you might see something similar to more than or increased by or something like that in the next problem. All right, so let's try example 5. Let me make sure it's the same. I think it's the same. You guys already have that one written down on your guided notes? Perfect. Okay, so take a minute and see if you can come up with an equation first, and then see if you can solve it to find the original price. I'm actually more interested if you can come up with the equation than I am the original price. So, start this. This problem doesn't say to check your answer. It just says to write an equation, solve the equation, and that's it. Okay. So the first sentence is basically just telling you what letter they want you to use. The original price is X dollars. Now, let's read the next sentence and kind of go through the important things. Okay. The price is important. How are we representing price in this problem? Yep,
X.
X. So I'm going to put that above price. Increased, that's important. What symbol in math means increased? Like if you're, in this case, increasing by 7, yeah? Addition. So we have addition. 7 is important. The word is. What does is mean in math? Yeah?
Doesn't it mean like the answer like equal?
Equal, yes. Is always means equal. And the next thing that's important here is the word 32. So let's look at the symbols that we just wrote down. X plus 7 is 32. Those are basically the symbols you need to write down your equation. Let's write it. So I'm just going step by step as I read the sentence. X increased by. You don't need to put the dollar symbol as you write the equation. We can just put that on the final answer. Is 32. So if this was a problem on the test, I'd give you half credit if you at least got that. Now the next step is to solve. Okay, how do I solve that for X? What do we have to do on both sides? Yeah.
Minus
Yep. And what are you going to minus from both sides?
32. 7.
Not the 32. Yep.
You have to subtract the 7.
We're going to minus the 7. So we minus 7 on both sides. That cancels the 7s on the left. And we get x equals, what's 32 minus 7? 25. And here's where we should put the label back on the number. What is that? 25. Positive 25. But what is that? 25 what? Dollars. Yes. So we just solved for an amount of money. And money was measured in dollars in this problem. So we put dollars. All right. Any questions on? Okay, so yesterday's video, again, it was about an hour. Today's video was about 35 minutes if I had stopped it while I was checking one of your problems. So a lot shorter today. So homework for tonight is the section 1.1, part 1 worksheet, and that is on Schoology. Just a reminder, we have our first test on Friday. And I will be after school Thursday if you need any extra help, or if you have free time during the day, you can always come by and I can help you.